We experience the world in three dimensions: length, width, and height. These three dimensions form the very fabric of our daily lives, shaping how we interact with our surroundings and navigate through space. These dimensions define our movement and perception. They are the axes along which we measure distance and direction, allowing us to understand our position relative to other objects and people. We move forward and backward, left and right, up and down. These 6 directions encompass all possible movements within our three-dimensional space, giving us a complete range of motion. But what if there are more dimensions than our senses can perceive? What if our understanding of reality is limited by the constraints of our three-dimensional perspective? What if our reality is just a slice of a much grander multidimensional universe? A universe where additional dimensions exist beyond our current comprehension, influencing the very nature of existence in ways we cannot yet fathom. Imagine a two-dimensional world, flatland, inhabited by beings who know only length and width. In this world, the concept of height is entirely foreign, beyond the realm of their experience. They can move within their flat plane but cannot comprehend up or down. Their entire existence is confined to a flat surface, with no awareness of the third dimension. Now imagine a three-dimensional object, a sphere, passing through flatland. As the sphere intersects the plane, the Flatlanders would only see a series of shapes changing in size. The Flatlanders would only perceive a series of changing circles appearing and disappearing mysteriously. To them, these circles would be inexplicable phenomena, as they lack the ability to perceive the sphere in its entirety. They would have no concept of the sphere as a whole because it exists in a dimension beyond their comprehension. Their limited perspective prevents them from understanding the true nature of the object. Similarly, we may be limited in our perception, unable to grasp the totality of higher dimensions. Just as the Flatlanders cannot perceive the sphere, we might be blind to the full extent of the universe's dimensions, waiting to be discovered. Albert Einstein revolutionized our understanding of the universe with his theory of relativity. He proposed that space and time are not separate entities but are interwoven into a single fabric, spacetime. This fabric is not static, it can bend, warp, and stretch under the influence of gravity. Imagine spacetime as a trampoline. A massive object, like a star, creates a dip in the fabric, causing nearby objects to be drawn towards it. This is how gravity works. Time, too, is affected by this curvature, slowing down in stronger gravitational fields. This phenomenon, known as time dilation, has been experimentally verified. Einstein's theory of relativity predicts that time is not absolute but is relative to the observer's motion. This groundbreaking idea revolutionized our understanding of the universe, suggesting that time can stretch and compress depending on how fast an object is moving and the strength of the gravitational field it is in. Experiments have confirmed this mind-bending concept. In laboratories around the world, scientists have meticulously tested and validated these predictions. They have used a variety of sophisticated instruments and techniques to measure the effects of relativity on time. Atomic clocks, incredibly precise timekeeping devices, tick slightly slower at sea level than at higher altitudes where gravity is weaker. This phenomenon, known as gravitational time dilation, has been observed in numerous experiments, providing strong evidence for Einstein's theory. Furthermore, time slows down for objects traveling at high speeds. This effect, known as velocity time dilation, has been confirmed through experiments with high-speed particles. This phenomenon, known as time dilation, has been observed in particle accelerators. When particles are accelerated to near light speeds, their internal clocks slow down, a direct consequence of Einstein's predictions. Muons, subatomic particles, have a very short lifespan. Under normal conditions, they decay in microseconds. However, muons traveling at near light speed are observed to live longer due to time dilation. This extended lifespan is a direct result of their high velocities, which slow down their internal clocks. These experiments provide concrete evidence that time is not a constant but a dynamic dimension. The implications of this are profound, affecting everything from GPS satellite technology to our understanding of the universe itself. Time, as we know it, is a flexible and ever-changing entity, shaped by the forces of motion and gravity. While Einstein's theory of relativity describes our universe in 4 dimensions, 3 spatial and 1 temporal, some theories propose the existence of additional spatial dimensions. These extra dimensions are thought to be curled up or compactified, too small to be directly observed. The Kaluza-Klein theory, for example, attempts to unify gravity and electromagnetism by proposing a fifth dimension curled up at every point in our four-dimensional spacetime. String theory, a more recent and ambitious theory, suggests that the universe is made up of tiny vibrating strings existing in 10 or 11 dimensions. The reason we cannot directly observe these extra dimensions, according to these theories, is that they are curled up or compactified at a scale far smaller than what we can perceive. Imagine an ant walking on a tightrope. The ant can only move forward and backward along the rope's length, unaware of the rope's negligible width. Similarly, we may be confined to our three spatial dimensions, unable to perceive the extra dimensions that are curled up at a subatomic scale. Section 6. Tesseracts and Beyond. Visualizing the fourth dimension. Visualizing a four-dimensional world is challenging for our three-dimensional minds. However, we can use analogies and mathematical concepts to gain some insight. A tesseract, for instance, is a four-dimensional analog of a cube. This helps visualize how a four-dimensional object might appear distorted and shifting in our three-dimensional perception. Just as a cube can be unfolded into 6 squares, a tesseract can be unfolded into 8 cubes in four-dimensional space. If a tesseract were to pass through our three-dimensional world, we would perceive a series of changing cubes, appearing and disappearing in seemingly impossible ways. Section 7. Encounters with the fourth dimension. A matter of perspective. Imagine a being from the fourth dimension interacting with our three-dimensional world. It would possess abilities that would seem godlike to us. It could appear and disappear at will, move through walls, and even see inside our bodies. This is because a four-dimensional being would experience time as a spatial dimension, allowing it to move through our timeline as easily as we move through space. Our perception of such a being would be limited by our three-dimensional senses, making its actions seem magical and incomprehensible. Section 8. Chasing Shadows, the Search for Higher Dimensions. While the existence of extra dimensions remains theoretical, scientists are actively searching for evidence. Experiments at the Large Hadron Collider, the most powerful particle accelerator ever built, are probing the fabric of space-time at incredibly small scales, hoping to find clues of extra dimensions. Additionally, astrophysicists are studying gravitational anomalies, such as the unexpected rotation of galaxies, which could potentially be explained by the gravitational influence of unseen massive objects in extra dimensions. The search for higher dimensions is a testament to our insatiable curiosity and our desire to unravel the deepest mysteries of the universe. Section 9. What if we already live in a multidimensional universe? What if our interaction with higher dimensions is not a matter of if, but how? Imagine a reality where the dimensions we perceive are just a fraction of the total. In this expanded universe, every action we take could have repercussions in unseen realms. The technology we develop, the art we create, and even the thoughts we think might resonate across these hidden dimensions, influencing and being influenced by them in ways we are only beginning to understand. What if our consciousness, our very being, is multidimensional, and we are only partially aware of our true nature? Consider the possibility that our minds are not confined to our physical brains but extend into these higher dimensions. Meditation, dreams, and moments of profound insight could be our mind's way of reaching out and connecting with these other layers of reality. This could mean that our potential for understanding and growth is far greater than we have ever imagined. Could our dreams, intuitions, and even spiritual experiences be glimpses into these hidden realities? When we dream, are we merely processing our daily experiences, or are we traveling through different dimensions, experiencing alternate versions of our lives? Intuition might be more than just a gut feeling. It could be a form of communication from these higher realms, guiding us in ways we don't fully comprehend. Spiritual experiences, often described as transcendent, might be moments when the veil between dimensions is thinnest, allowing us a brief but profound connection with the greater universe. The exploration of higher dimensions is not just a scientific endeavor but also a philosophical one. It challenges us to rethink our place in the universe and the nature of reality itself. Scientists and philosophers alike ponder the implications of a multidimensional existence, debating how it could change our understanding of everything from the laws of physics to the nature of consciousness. This exploration invites us to open our minds to new possibilities and to question the very fabric of our existence. It challenges our fundamental understanding of reality and invites us to consider the possibility that our universe is far more complex and wondrous than we ever imagined. As we gaze at the stars, we might be looking at just a small part of a much larger, more intricate tapestry. The night sky with its countless stars and galaxies could be just one layer of a multidimensional cosmos, each layer more fascinating and mysterious than the last. The journey beyond the familiar three dimensions is a journey into the unknown, a journey that requires us to expand our thinking and embrace the mysteries that lie beyond our current understanding. It is a journey that could lead to new discoveries about the nature of space, time, and existence itself. By exploring these unknown dimensions, we might unlock secrets that have eluded humanity for centuries, opening up new frontiers for science, philosophy, and spirituality. A journey that promises to expand our horizons and redefine our place in the cosmos. As we venture into these new dimensions, we may find that our universe is not just a vast expanse of space, but a complex, interconnected web of realities, each one offering new insights and possibilities. This journey into the unknown is not just about discovering new places, but about discovering new ways of thinking, being, and understanding our place in the grand scheme of things.